Hey, welcome everyone. Good morning, good afternoon, good evening, good night, depending on where you're coming to us today, or to me. And I have Rebecca and I think Gil, or Gus, excuse me, Gus, helping me out today virtually. So I want to thank them for helping out. Welcome to Past Virtual Summit 2020 in the first session slot. Thanks for joining me today. My name's Jamey Johnston. I think this is my 8th or 9th past summit to attend and my 6th one, I think, to speak at now. So really happy to get to speak. Not so happy that we're all virtual, but we make do with what we have to in these times. And glad everyone's here today. So hopefully you're in the right session. This is the one you wanted to join. Code Like a Snake Charmer version 2.0 introduction to Python. So I've given this talk a few times. I have some new code, a couple new slides, but we have some really good code to show you, to kind of walk you through all of Python and building data models and using it for predicting against your data and things like that, right? So it should be a fun session. So I'm a senior data scientist, data engineer for a oil and gas company here in Houston, where I live. And I've been doing this for quite some time now. So I kind of enjoy it. So hopefully you're in the right place, and let's get started. So what does PASS have to offer for you? So pass.org, you've all been there because that's where you would have signed up for the summit. They also have now this pro member, where they have exclusive training and networking opportunities. Don't miss past local groups. There's local groups all around doing sessions, all virtual these days. But once we get back to be able to meet again, they'll be meeting in person, I'm sure. But there's local groups all over meeting and talking. Past SQL Saturdays. This is actually where I got started in Past. I went to SQL Saturday in Houston back, gosh, I don't remember now, 2011, 2012, something like that. And that's how I got involved. And then Past marathons, these are usually 24-hour events that Past has, where they have a session pretty much on every hour on the hour, just on a topic. And then virtual groups, I actually help with the Past data science virtual group, but we have lots of virtual groups at Past. And then Past volunteers, it's your opportunity to give back and get to be a part of Past. So you can check that all out on pass.org. Session evaluations. So be sure to submit these evaluations. I do read them, and I do use them to try to make my session better. And also, you can win prizes. So if you submit them before Friday, November 20th at 5 p.m. Eastern time, you'll be eligible to win prizes. I don't know what the prizes are, but usually there's a few good ones. So definitely, recommend that you sign up for the do the session evaluation so that you can win some prizes. So if you see me do like this is me pointing in my second monitor. Like you can actually see me doing that, because I usually speak live a lot more than I speak virtually. And so I tend to use my hands a lot and do all that and point. But of course, you can't see where I'm pointing. But if you see me do like that, that's just pointing to the slide or to what the screen you're seeing. So session evaluations, do them because you can win prizes. Just a little bit about me. I don't have kids, but I got 2 dogs. One of them who might probably will at one point, when she gets tired of sleeping on the floor here, she'll probably try to jump in my lap. So if she does, that'll probably be fun. But yeah, I do have dogs, no kids. LinkedIn, you can get me on LinkedIn at Jamey J. That's where you can get my LinkedIn profile. And then follow me on Twitter at StatCowboy. The things that are important, I do have a blog. I don't blog a lot, but I do blog a few times here and there a year. Did some cool blogs on Power BI this year on an intro to Power BI and how to use the coronavirus data that Johns Hopkins has to learn Power BI. And then the main one that you might care about is this github.com/datcowboy. That is where you can find the code. I think if I drag this screen over, you can see that. So if you just, when you get to the main page, I have it pinned right here under Stack Cowboy Snake Charmer V2 intro. And this is where all the code and everything is located. So that is the important part of this slide, is where can you get the code I'll show you today. So, and I did go to Texas A&M for my master's in analytics, which is applied statistics. And then went to LSU for a bachelor's in spatial analysis. I'm actually I'm a visiting professor at A&M now, and actually teach in this program. And I actually teach deploying Python models as a class there. So enough about me. Why did you come here? Well, this is why you came here, to learn about Python. So this is an intro to Python. It's not an advanced Python. It's not a, stats class. It's not a machine learning class. It's more to teach you Python. We will go through an example at the end where I'll walk you step by step using some Fannie Mae, Freddie Mac data from 2007 on loan defaults, where we'll build a logistic regression model in Python to try to predict when people will default on their loans, if people will default on their loans, with a bunch of data. And we'll wrangle the data in Python and massage the data and introduce some of the things I'll teach you about the language and getting started with the language, and show you how to put it all together into a model. So that's what we'll end up with doing at the end in a demo. But today, before we get to that part, I just want to give you the basics of the language. The idea being that you might have been exposed to programming languages, but Python is new to you, and this is what and that's why you're here today, to learn Python. So I'll give you a little introduction to Python, go over the distribution that I use for Python, which is Anaconda, the IDEs that are available to you, so the tools that you can use to write code for Python. And then go over some of the syntax. What does the basics of Python look like? And then go over some of the packages like Panda, some of the control flows, and then show you just a couple of places where Microsoft has incorporated Python into their products. So that's the agenda. I just noticed my packages is in the wrong place. It's actually up here under the Anaconda and IDEs. We'll cover it there. Anyway, I digress. So, introduction to Python. It is not named after the actual snake. It's actually named after the movies, the Monty Python movies. The person who wrote Python was a big fan of the Monty Python movies, and that's where the name Python comes from. It is very popular because it's a huge open source library. Pretty much everybody who's writing tools around data science, and machine learning these days tend to write all their modules and functions and everything in Python first. And then it might make it down, then it'll make it down to R or other languages. It's a very easy language to learn. It's very, very simple. There's no compiling or anything like that. And like I showed in the agenda, Microsoft has got a lot of investment in putting Python into their tools. So things like Azure Databricks, Azure Functions, Azure Machine Learning, SQL Server, also Azure Synapse Analytics, Azure Data Studio, quite a few. I'll just highlight them at the end. We're not going to demo them, but I'll highlight them more again at the end just real quick and have some links for you. But just where you can see where, hey, once you learn Python, since we're kind of we're at PASS, which is typically Microsoft heavy, Microsoft sponsored. Most of you probably are Microsoft people. So I'll show you where you can use Python in Microsoft. And this is a code 0. It's 7 in the morning where I am at. So I haven't started that early. So it is the most popular programming language, Python. In 2018, it was number 1. I think 2017 was number 2. Then 2018 was number 1. 2019 is number 1. I'm sure 2020 will probably be number 1 again. It's an interpreted language, like I mentioned earlier. So there's no compiling and linking necessary. So you just write the code and you can run it. And it's super fast. So that's one reason why people like it. So how do you get started? Well, first you have to get the language. You have to go and actually download and get Python. And so there are several distributions. You can go straight to like Python and get Python executables there, but most people use the Anaconda distribution. So it is a packaged version of Python that's packaged up, that gives you lots of tools to help manage your Python environment. The Anaconda distribution, the full distribution is available at this link. I think I say download 3.7. I think it's actually 3.8 now. Excuse me. I think 3.8 is actually what's up there now, the latest version. But just download the latest 64-bit version of Python, install it, and you'll be able to run whatever version of Python you'll need. Well, I'll show you this in a second, how you can use the Conda manager to set up your Python environments on your machine to set up what version of Python you need. Because certain packages you might be using require certain versions of Python. Some might only support like 3.6 or 3.7 Python. Others, if you're really, really old, but you're hopefully, if you're trying to really use really old modules, you might need 2.7, but I don't believe 2.7 is supported anymore. I think the support has run out on that. I haven't had to use 2.7 in a long time, but even if you downloaded and installed the 3.7 distribution of Anaconda, you can still set up 2.7 versions of Python if you needed to. But having said all that, Anaconda, I like Miniconda. So it's the same Anaconda Continuum IO people that do this, but they create a smaller version of the Anaconda distribution. That's just kind of the basics. It's all the basic what you need for Python. So this full distribution here in this top link has a lot of bloatware, I'll call it, that comes with it that you really don't need. So I recommend Miniconda. It's what I use. It's a lot smaller, a lot lighter, but it'll give you the Conda manager. It'll give you the Python, language and tools and everything you need to write Python code. So that is what I recommend. I want to actually go and actually install it for you. Just click on the link, click on the executable, run it, take the defaults, and you're good. So this is how you get started. This is what's going to give you the Python executable so that you can run Python code. So again, I recommend Miniconda. One thing I didn't mention in the introduction, I don't know if you guys have questions. I will take the questions at the end, just because we're doing this virtually and sometimes it's a little harder to try to interject and take questions. But Becca's watching in the question pools, and she's gonna, at the end, give me all your questions. If you're having any technical issues, obviously ask those questions now as well. But Becca and Gus are watching to help with that. But I just realized I meant to mention that earlier on. If you have any questions, just save them to the end, and I'll cover them I'll answer those at the end. Because I think you'll find sometimes the questions I'll answer in the next slide or a subsequent slide. And then, like I said, the other thing is it'll be a little easier to answer things at the end. So Anaconda, this is what pretty much most people use these days for their Python distribution to get the code. So Anaconda comes, the main thing that's really nice about the Anaconda Miniconda distribution is the Conda, and it's the open source package management system and environment management system for Anaconda and Miniconda. And what it allows you to do is to set up your environments for running your code. So what you'll find as you start writing code is, unlike say Visual Studio, where you're running C#, you just have one install of Visual Studio and you have C# and you run C#. With Python, you'll find that you'll have you'll set up different environments with different versions of Python with different packages in there, depending on the projects you're working on. So I typically take the approach when I'm working with Python and writing code is to create a environment for project. When I say environment for project, what I don't mean is I install multiple versions of this Anaconda or mini Conda. You install that once. But once you install that, you get this Conda package manager, environment manager, and it's going to allow you to set up multiple environments, which are just directories that have the Python executable in there, the packages in there. And each one of these directories can be set up with its own version of Python, its own packages. And so I tend to have my an environment for project, right? And so then also what I do is if I need to upgrade packages or upgrade Python, I'll create a new environment using the Conda environment management system with the new version of Python and the new versions of packages. And that way I can test my code against it. If I have any issues, I still have the old versions. And I'm going to demo that in a second. One thing I like to do is when I run Conda, so once you install the Anaconda or mini Conda, in my case, mini Conda. So if you look right here, you can see where it says mini Conda right here. This is because I installed the mini Conda version, which is what I recommend. You get these Anaconda PowerShell prompts or Anaconda prompts, and these launch the Conda manager that looks like this. So this looks like this. And so then I can run a command called conda env list. And then you can see all the different environments that I have set up for different projects in my Conda environment for different versions of Python. And see, and they're just directories. And so when you run this Anaconda prompt, I tend to run it as admin on my machines. That way they get installed in the C program data mini Conda envs folder. It's up to you. If you don't run it as admin, the prompt, and you set up your environments, it's going to create them in your profile. It's not a problem. It's really a preference. I just tend to run it as admin so that they get installed in the root folder. If you didn't install mini Conda, this will say Anaconda 3 for your folder. But just to give you kind of idea what it looks like, I'm going to go to one of these folders real quick. And I'll zoom in a second. And so you can just see right here in that folder, you can see each one of these folders has the version of Python in there. So I'm going to demo this a little more, but just so that you kind of get an idea of what an environment is, I just wanted to show you that real quick. So and that's all it is. After you install the mini Conda Anaconda, this Conda manager allows you to run it and create these different environments, install packages and whatnot. And so this is just a shot to show you how to run it as admin. This is all on Windows. If you're on Mac or if you're on Linux, which you can install it, it's a little different. But I tend to work in Windows most of the time. I do work some in Linux. Excuse me. Early in the morning, so I'm still a little dry in the mouth. So this is when you run so when you're working with, after you install it, you use the Conda package manager or the Conda environment package manager to set up your environments and manage your environments. Like I said, I recommend running it as an admin so that you can have your environments get set up in the root folder where it's installed. So under C program data. So what are some commands? These are just some screenshots of some commands. I'm not going to demo all of them, but if you want to upgrade your Conda, these are upgrade the packages and environments in your Conda environments. These are the commands to do that. This right here is important. This one right here. So this is how I set up environments. So when I did that Conda env list and you saw those environments, these are the name of that environment. This is the version of Python. So this right here is what specifies what version. So it doesn't matter what version of the distribution you downloaded from Anaconda. That's why I say get the latest. When you create these environments, it allows you to specify what version you want of Python in that environment. And so in that Conda prompt, we issue these commands, and this will create a folder with this version of Python in it. And then we use this conda activate command to make that active in the environment. And then, excuse me, we can do things like install packages or whatnot. And so this is what this conda prompt and this conda environment manager, package manager gives you. This is why a lot of people like conda, because it has a whole distribution and management system around it to just make it very easy to manage your Python installs. You saw me do the conda env list. This shows the environments you have set up, so the different Python environments in your conda distribution. There'll be a star next to the one that's active. So when I did that conda env list earlier, there'd be a star next to the one that's active. What that means is just the variables and stuff are set in that prompt. So I'll just show you that again real quick. So if you see right here, you can see that this one is the one that's active. That's why there's a star. And that just means that when I type like Python, it's going to use the version of Python that's in this version right here. Conda list, this is when you're in an environment, you list this list of packages that are installed. So packages, I'll talk about it in a second, but packages are just enhancements, extra things that people have built to make Python that are beyond the base packages that come with Python to help you in writing code. If you want to remove an environment, so like if you created one and you want to delete it, you can do it this way. And then if you just want to update a package in Conda, use that Conda update. So this is a really cool feature right here. So once you set up an environment, you can actually export that environment to a YAML file. And then, and I'll show you what that looks like. If I go right here, and I click right here. So this is what a YAML file looks like. So it shows you the name of that environment, and then it shows you all the dependencies. So basically all the packages that are installed in that environment. And what's cool about this is you can then take that YAML file and create a new environment. So if you want to easily clone an environment, or if you want to say, hey, your environment set up, and now you want to share it with the coworkers because you're working on the same project, you can, excuse me, sorry. I'll try to mute next time if I have to cough. I apologize. Man, early morning sessions are hard. Sorry. So back to my point before I started coughing on you. Apologize. A lot of times what happens is you'll create a Python environment that has the right versions, the right packages to work on a project. Well, if you want all your, like say you're working as a team and you're all developing code for the same project, you well, obviously you want to use the same versions of the packages and the same Python versions. You can then take that environment, set it up, export it to the YAML file, give it to your coworkers, and then they can just run this conda env create with that YAML file, and it will create an environment for them with the exact same package versions and Python versions as you. And then now you know that you're coding in the exact same version of Python with the exact same versions of the software. That way you don't run into any errors as you start putting your code together and whatnot. So this is a really cool function. Use it all the time. That being said, if we go right here and look in my repository, I have a YAML file out here. So you can just download this YAML file and you can run it, and it will create the environment you need after you install Anaconda or Miniconda to be able to run my code. And it'll have all the packages already installed so that my code will work right for you. The other thing I do have is if you don't want to use the YAML file, and I'll demo this in a second, and you just want to, if you just want to set it up from scratch, here's the conda commands to set up that environment. So it'll create an environment called past 2020 intro, Python 3.7. Then I'll activate it, and then this will install the packages that I'm using for all the code I'll show you today. So that is Anaconda. So I mentioned the word packages a few times. So packages are just, so Python comes with some default packages, and these are the default packages that have the base code and base things for the language. Well, as you're going to go and write, I'm assuming most of you are probably in this session because you want to get into data science, or you want to write code against data, right? Well, as you start doing that, you're going to need additional packages to do that. So things like Numpy and Pandas and scikit-learn. These are all packages that people have written for Python that extend beyond the base Python, that give you all this functionality to write code, right? And so to install these packages, you have two ways to do that if you're using the Anaconda or Miniconda distribution. The first one is the Conda. So this is the Conda. I've already shown you a couple commands for creating environments, but also the Conda command can be used to install packages. So this is just an example right here of using the command install PyODBC. So as you can see from ODBC, you can guess what this is. This will give you the functionality to use ODBC drivers to connect to data sources. So this is how I would install that using the Conda command. Some packages, for example, TensorFlow. TensorFlow is written by Google for Google. This is their deep learning neural net package. It's not available in the Conda distribution. And so since it's not available in Conda, I have to use pip, which is the default Python package manager to install it. So my rule of thumb is I usually try Conda first, and if it doesn't work, I try pip. Now, that being said, I highly recommend, zoomed into the wrong spot. I highly recommend look at the package instructions first. So a lot of these packages have web pages and have install guides, and you can look at those install guides, and they'll tell you exactly how to install them. So, for example, TensorFlow, has an install thing right here, and it basically just tells you to do pip install TensorFlow, right? So they don't really have a Conda version available. So that is packages. So on how to install them. So Conda, try those first, then pip. But like I said, always try to go and look and see if there is install instructions first. And if they are, just follow those, because they'll tell you if you use Conda or if you use pip. And sometimes when you're looking at those install instructions, a lot of times they'll list pip first, but then down below they'll have, oh, if you have the Anaconda distribution, then run Conda, blah, 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 right? Install and install it that way. So just know that sometimes the instructions will list how to install it with Conda or with pip. So popular packages, Pandas. This is a package for giving us data structures and accessing and tools to access data, like so we can read data from CSV, JSON, ODBC, and they'll read it into series and or data frames. PyODBC, I already mentioned that. Matplotlib, it's a plotting library built off of like MATLAB. It's supposed to kind of mimic what you do in MATLAB. So this is how we can do plots. Scikit-learn. These have a lot of data mining, data analytics, statistical models in them. Numpy gives us n-dimensional arrays. Package, SciPy, another package for math and stats. And then TensorFlow and keras. I don't have PyTorch listed, but PyTorch is another package by Facebook that can do to develop ML deep learning models as well. And then keras is I kind of think like a wrapper package around these TensorFlows. I love CNTK. These are other CNTK's Microsoft's deep learning package. Keras is a kind of a wrapper that kind of abstracts accessing the libraries in these TensorFlows and other ones to make it easier to use. In fact, TensorFlow 2.0 is it's got the keras kind of is built into it, how it works. Well, these are just some of the popular packages that you'll install to make your environment work. So real quick, let me just give you a little guide. I'm gonna go to the root just so that you can see my commands. So I've already showed you conda env list. All I did real quick is just go to get this prompt. I have a screenshot already. I just went right here, right click, more, run as administrator, and this prompt came up. And this gives me my conda prompt. So I already did conda env list. And I will pause real quick. Can one of y'all let me know if when I zoom in, if you can see the font? Okay, I do want to make sure that y'all can see it. So, so this lists my environment. If I want to go and create an environment, so a lot of times, if let's say I'm going to create a new project, and let's say I'm going to do a project to classify red wine, and so I'm going to call it the red wine project, and I know it needs Python 3.7 because that's the packages I'm going to use require that. So I'm going to call this environment red wine, and I'm going to say it's going to use Python 3.7. So you can see that's that command. This is in the slide deck, and it's also in the downloads, these commands. So real quick, I'll just pull this over again. I'm not going to run all these, but this is the command I just ran. In this case, I called it red wine. And then I'm just going to install a couple packages off of this list just to show you what it looks like. Give me 1 second here. All right. So notice when I did the conda create, it gave me some of the default packages it's going to install. And I say yes. And then it's going to set it up. And it's going to download the packages if it needs to. It won't need to download the packages because I've already installed them before. Notice how it was real quick. And then I can run this conda activate command to activate it. And the reason I do this is so that the environments are set up and it's in that I'm using that new install that I just created. Notice it put it in this folder right here. And so now I can start installing packages. So I can do like Seaborn. So Seaborn is a graphics package, kind of like. I was just checking the chat. Sorry, guys. Y'all said it's look. Y'all can see it good. Okay, cool. So Seaborn is a graphics package. I like to install it, and I'll show you this first. I usually just go ahead. That's like usually every environment I set up, I install Seaborn first. And the reason is because there's dependencies in packages, right? Well, Seaborn requires things like SciPy. It requires Pandas. It requires, I think, matplotlib. So this package is built upon a lot of other packages that I use. And so I like to install Seaborn first. And then I get Pandas and matplotlib and NumPy, or you might hear it called Numpy. I forget. I call it NumPy because it's not Python, it's Python. But some people call it Numpy, but you call it whatever you want. But I've never heard a Python or Monty Python called a Monty Python or a Python snake. And so my guess is it's NumPy and not Numpy, but I don't know. Some people call it GIF, some people call it GIF. It's still good peanut butter. So this is just going to install some packages, and then, I mean, I'm not going to probably go install anymore just because of time, but this, you can go down the list and you can see down here, if you want to set up your own environment to run my code, you can use the YAML file, or you can use these commands in your prompt and just run them. Notice I have a few of them that require pip. So this is where TensorFlow keras XGBoost is gradient boosting algorithm to do modeling. I have an example code of gradient boosting and TensorFlow. I'll show you at the end. But these are not available through Conda, you install these through pip. So hopefully that makes sense. And we're going to move on because I've spent a little more time on this than I wanted to, but it's very important because the reason why I've spent so much time is because this is an intro. And one of the things that frustrated me when I first started, so I wrote Python like 20 years ago and on a Solaris box, on a Unix box. And, and you just ran Python. It was whatever version was installed and you just ran Python. And then 5, 6 years ago, 7 years ago, when I started writing more Python again, as when I started getting back into doing more data science stuff, I started to learn started getting Python. I was like, well, how do you get started? No one had a lot of resources around like Anaconda and what to do. And so that's why I've spent a lot of time on today, because it's going to make your life easier. And so the one point I will make, set up environments per project and, share those environments with your coworkers. If you're working on the same project, that'll make your life a lot easier. So now I've talked about the Anaconda distribution. This is just the, excuse me, Python language and the environments, and we're going to run Python. Now we want to write code. Well, how do we do that? Well, there's lots of IDEs out there that like to write code. PyCharm is one of the most popular ones by JetBrains. I used to use PyCharm. Now I use Visual Studio Code because Microsoft has a really awesome Anaconda and Python extension that they've added to Visual Studio Code. And so I really, really like Visual Studio Code these days. And this is what I code in. Spider is another one that comes with the Anaconda distribution. I do know a few people use it. It's not bad, but the two most popular ones that I see people using from an IDE standpoint these days are PyCharm, definitely the most popular, and Visual Studio Code. Both are free. So I'm just going to talk about Visual Studio Code real quick and then go on. So some important things about Visual Studio Code. They have a good they have a good tutorial at this link right here. One thing to note, I'm going to demo this in a second, but to run code in your Visual Studio Code, Shift Enter. So you highlight the code you want to run, hit Shift Enter. One important package to install, and you saw I have it already listed, so in case you forget, it's on the slide right there, but also is this Pylint. And what this is Pylint is the package that gives you the squiggly lines when you have bad code. So it's your syntax highlighting. So that's why you want to make sure you install Pylint. You also, in your Visual Studio Code, you want to make sure you install the Python and Anaconda distributions. The Python and Anaconda extensions. And then the reason why I like Visual Studio Code a lot is they have the IPython console support and this Python interactive window in Visual Studio Code. And I'll demo this, but this is what's kind of flipped me over to Visual Studio Code about 2 years ago at the first part of 2019 when they introduced this latest extension with this Python interactive window support. So, and what this does is allows me to run my Python code. It will then run it in this interactive window, like in a notebook. So it's really, really cool. So like I said, important note, install Pylint and install the extensions for Anaconda and Python. One important thing to note too, to use this interactive window, make sure you install this package right here, notebook. This is what makes the interactive window available. So, all right. So that's just some shortcuts on Visual Studio Code. Another way that's very popular are Jupyter notebooks. So you'll hear the word notebook used a lot. Azure Data Studio has notebooks now. Azure Databricks, Azure Synapse Analytics, Azure ML. A lot of tools have this notebook environment, and it's all kind of built off of this Jupyter notebooks. And what you get is this kind of, I'm not going to really demo notebooks today, but what you get is this experience looks like this. This section right here is a markdown section. So this is just HTML-like code. And you can't actually use HTML in these markdown sections that are like your syntax. I mean, this is just your comments and descriptions about what's going on in your code. And then you have these code blocks. And I'm not going to try to write with my mouse again because that's terrible. But then you have these code blocks. And this is not a code block. This is a markdown block. Let me get rid of that. So, and then you have these code blocks. And this is actually where your Python code goes, right? And so you can make these HTML markdown blocks. Then you have these code blocks, and then you can run your code blocks. And then this creates a really nice experience for working and writing code. I typically like to write my code in Visual Studio. If I code, excuse me, Visual Studio code, but excuse me, certain environments you can't, like Databricks. You know, it's a workbook, notebook experience, and you have to write your code there. But so it is a really cool thing. Now, one thing I do a lot is as I'm writing my Python code in Visual Studio, once I have it good, so like let's just pull up an example. So we're gonna go over this here in a second. But like once I have my code worked out, and see I have all these comments and different things right here, right? I might take this code and move it into a Jupyter notebook, and then take all the comments and make them markdowns and add syntax, and then use that notebook to go explain to like my boss what the code's doing and how it's working, because it just gives a richer experience than showing him or her this, right? And so, you know, looking at code is kind of boring, but in this notebook experience, excuse me, it looks a little cleaner and nicer. But the reason why I tend to try to write the code, I write my code in Visual Studio code first, it's just it's easier to debug there. Notebooks are, when they have, you know, it'll, like in this case right here, you'll see where, you know, oh, sorry, where it puts the output down here, but it's a little harder to debug in the notebook. So that's why I tend to not start out writing my code there. The only time I start out in a notebook is if I have to. So if it's a product like Azure Databricks or Azure Synapse, where I have to use a notebook to write the code against it, then I'll use the notebook. But it's preference. I'm not telling you to use Visual Studio Code over Jupyter Notebooks. I have lots of friends that just do everything in Jupyter Notebooks and they love it. So, but you can install the Jupyter Notebooks and run them in your code. So I'm going to demo the IDE Visual Studio Code at the end when I actually show you the code. So let's get started because we have like 30 minutes left, right? So let's just, I'm gonna go real quick through syntax of Python, and then I'm gonna jump right into some code, okay? So comments, #, multi-line comments, 3 single quotes. So that's just start from the beginning, work through, and then I'm gonna show you code. So operators, so they work the same way you expect in other language, plus, minus, star, pound. So plus, subtraction, addition, multiplication, division, right? So these are just some examples, right? Code. And the one thing to note is any code you see on these slides, I actually have it all right here. So you can run it. And this is all downloadable. So single quotes or double quotes, they work the same here in Python. See? Escape single quotes. So if you're using single quotes, you need escape, use a \. If you need to concatenate strings, use the plus, right? And then if you want to repeat strings, you can use the star. So this is an important slide, slicing and indexes of strings. And this works the same with anything in Python. Python starts with 0, but it doesn't include the last number. So when you're slicing, you have to actually go one number more over. So that's why this 16 here, even though, so this is the tax pass summit 2019. I forgot to change that to 2020 here. this is the text. So these are 15 characters long. That's what this is showing you here. So P is 0, the 9 is 15. Unfortunately, in Python, when you do slicing, so if you're saying, hey, grab this part of the string, the last number you give it is not inclusive, it's exclusive. So it doesn't actually get it. So if you said 15, so that's why you have to do 16. And then reverse, you have starts with -1 and goes that way. So length will return the length of a string. And I'm gonna go real quick through this because we're gonna see this in code in a second. But so this is important. So what are the common data structures in Python? So we have list. They're done with these square brackets. And so this is just a list, and it's got 4 values in there, and these 4 numbers, 1, 2, 3, 4. That's a list. You can slice list by using the list name with the bracket. You can concatenate lists together. So lists are mutable. You can change them. I think I missed a slide. Oh, no, I didn't. Sorry. You can append a list using the append function. You can replace a slice. So you can actually say, hey, replace a portion of my list with new values. And then to get the length of your list, use the len function. So that's list. Then you have tuples. Tuples are a number of values separated by commas. You can list tuples, but tuples are immutable, meaning you can't change them. So they're kind of like lists, except for that you can't change them. My guess is tuples existed back. Tuples and list, tuples kind of came about when the language was really, really new and memory was really expensive and you didn't have a lot of it. And because there's overhead of maintaining structures to be able to do things in lists like slice and dice and make immutable. And I think that's why you see tuples, but tuples are kind of like lists, except for they're immutable. And then you have dictionaries. So we have lists, we have tuples, and we have dictionaries. And dictionaries are key value pairs. So I can have a key, and then I can have a value, right? And then that value actually cannot not only just be a number, it can also be another data structure. So I can have a key, and that value could be like a list or a tuple. So like I could have a dictionary that's a location, and so the name can be the name of the location, and then the value of this dictionary could be a tuple, which is the Latin long of that location. And so you can delete items in dictionary using the DEL. You can list your keys. And just these are more, these slides are just kind of, just go back through them again, right? This is kind of lists, they're brackets, they have values, you can change lists, tuples, they don't have brackets, they have these parentheses, you can't change them. So once they create them, you have to either recreate them. And then you have dictionaries, and they're with these squiggly brackets, and they're these key value pairs. So then we have Pandas. So Pandas is a package you install, and then Pandas give us data structures. So they give us a data frame. So think of a data frame like a table, has columns and rows. They give us series, just think of series like one column or one row, right? And then they give us the input-output tools like CSV, Excel, ODC to bring data into Python. And I'm going to show you Pandas a lot here in a few minutes. We have NumPy. This gives us n-dimensional arrays, linear algebra, random numbers. And so these gives us a multi-dimensional array structure to bring data in. We use NumPy arrays a lot when you start dealing with deep learning with like TensorFlow and with things like that. Or even, actually, we're going to use NumPy arrays here in a minute either. Well, we'll bring data into a Panda data frame, but then we'll actually convert them to NumPy arrays to actually do the actual the data analytics. But these multidimensional arrays are really fast, but they allow you to give multiple dimensions besides like rows and columns. So you can have 3, 4, 5 dimensional arrays, and then and then we start dealing with deep learning. We have these multidimensional arrays where we're trying to do like image classification or things like that. So NumPys are used a lot for that. So an indentation. So this is a very, very, very important slide. So Python is all about indentation. So if we look at like a block of code, and so if I come right here, we're going to go through this code here in a second. if I look at this block of code and I look at right here, this is a function right here, right? And if we scroll on this function, you can see where I have def. This tells me I'm defining a function. Name of my function takes in this value score, has a colon to end this line, and then I hit enter, and then I have 4 spaces. And then I have an if statement, and I have 4 spaces. These have to be the same. They're not tabs, they're spaces. And the way these end, notice there's not like an end. There's not like in most programming languages where you have a squiggly bracket to start and a squiggly bracket to end. In Python, the way you end is you just go back. So this if ends right here, and this function ends right here because we're going back. And so indentation is how Python distinguish blocks of code. And it's very important to not use tabs. It doesn't use tabs. And this is why I say copy, paste don't work. And so the reason why I say that is a lot of times you're going to go to the internet, find a piece of code and go, that's exactly what I'm looking for. And you're going to highlight it, Control C, Control V, drop it in your thing and run it. And it's not going to run. And it's probably because by default, when you copy something from Chrome or Excel, or Edge, it converts spaces to tabs and things like that. So just be very careful when you're writing your Python code that you are familiar with that it uses indentations and it's spaces, it's not tabs. And then as you copy code from the internet, you might run into issues if you're not careful. So make sure you turn off tabs. I like to use 4 spaces. Some people use 2, some people use 8. I probably wouldn't use 8 because like, if you look, for example, like look at this code right here. This is 8 right here. If I started using 8, I don't have much space left to write code, right? So intentions, very important in Python. Control flows, equal to. So if something's equal to something, you use 2 equal signs, not equal, less than equal, greater than equal. Things that if you're familiar with, some basic programming, these look familiar to you. So if then else, so there's no then, it's just if, elif, else. So this is what the if else statement looks like in Python. Notice the colons, notice the 4 spaces and the indentation, right? So if and in. So if 2 is in and this is a list, remember the list has a bracket. So 2 is definitely in that list. I'm going to print, I found it. Else, I'm going to print, keep looking. So print statement, one important thing when you're looking at code and on the web, and if you see print with no parentheses like this and just says print space found it, note that that's Python 2.x code, not Python 3.x code. So what that means is there's slight differences between 2 and 3. You can go find out python.org has a thing that says what the differences are. But most code has print statements in there somewhere. And so if you see a print and a space with no parentheses, so if it looks like this, and it just says print, and I'm not very good at writing mouses, and then it says double quote, hi. I'm writing with my trackball. So it looks like that, but it'll be prettier because it'll actually be real font, and there's no parentheses. That is 2.x Python. So, but this is the in operator, kind of like SQL, right? It's in a list. For loops. So for I, I'm just setting a variable I in this list, print. So I'm going to iterate through that list and say 1, 2, 3, 4. I'm going to create a list called word list here called Jamey, Melanie, Stephanie, Robin. That's me, my sisters, and my wife. And then the cool thing in Python, I can iterate that list with for word in, word list print. So see how these for loops work? Just giving you the syntax here, right? Range. So I can use this range function. So R equals range, print R, and then for num in R, print R, and then I can grab whatever index I'm on in that range. And so it'll go 0, 1, 2, 3, 4. So I'll print out 5 values starting with 0, 0, 1, 2, 3, 4. So for and zip. Zip is a really awesome function, in Python. I can have 2 lists, and then I can say for Q and A in zip, and then give it those 2 lists. And then I can extract the first element from the first list, this Q, right here, see format QA. So I'm just using this little format function. So what is your name? It is Jamey Johnston. What is your birth year? So as it loops through, what is your birth year? It is 1974. That is my birth year. What is your occupation? It is data scientist, right? So that's that cool zip function. That's a really cool thing that I like about Python. For loops and dictionaries. So you can have a dictionary, and so you can say for, and then you give it two variables. In this case, I sorted it by the keys, so by name, and then I can say print K, so that's going to be the key was born in the year, and then V is the value, right? Print. So this is how I can loop through dictionaries, get the key and value pairs. So Python supports like break and continue. So like if you have for loops, I'm going to break out of them, continue. That's supported. I have a little link there for more information on that. I want to go because I have like 20 minutes. I want to get to the code. So try catch, try except. Python supports that. So try, accept, break, continue. All that's supported in Python. Here's some example right here. While loop. So num is equal to 0. While num is less than 10, print num, and then increment the num, right? And so that's just an example of a while loop. And then functions. I showed you a function earlier in this code, this function right here. This is this function. I'm going to show you this code in a second. This is a function right here. Oh, where did my code go? Sorry. So just name, they always start with def, and then they have a name, some variables. Notice if you have non-default parameters, so like year doesn't have a default to it. So those non-default parameters go first, and then in this case, name has a default, meaning if you didn't give me a name, set it to none, kind of like null. Think none like null, right? So that way I can say if name is not none, print welcome to pass, your year and the name. Else, if you gave me your name, I can say welcome to pass and the year, and like that. And you can see this is what I can then call those functions like this, right? Classes and objects. So Python supports this class structure. So I can define this class, have some functions in that class, and then I can then have a main function so that when this Python code gets run, it runs this main, and then it says prod equals this class database, prod. Let me zoom in a little. And then I can then instantiate another instance of this class database called dev, right? And then as you can see, they have these different functions that are inside of them, right? And then I have in the code here, if you want to play with this class function and understand how it works, I have the code right here for that. So it's in the downloads. All right, so let's get to the demos. But real quick before I get to the demos, I'm not going to talk about these slides, but for more than just 2 seconds, Microsoft, you can run Python and SQL Server via this spexecute external script. You can use Azure Machine Learning and run Python. And they have notebooks. You can run it in several places there. Azure App Services, Azure Functions, Azure Synapse Analytics, Databricks. There's a session after this in this path, that learning path. I think Chris Hyde's next, and he's going to talk about Databricks and Python. And then BI, Power BI. So you can Python supported in Power BI. And then finally, the new tool that Microsoft called in the last few years called Azure Data Studio. It supports notebooks, and you can actually run your Python in Azure Data Studio. So those of you who might be DBAs that are using Data Studio already, you can use it there. And I'll also have a few references at the end. I highly recommend this book. You can see it right here. I even have it sitting right here. Google has a good guide. There's the docs, the actual official docs, the Python. Coursera has some good courses, and Microsoft Academy, really good courses. So I'm going to leave it on this slide, and I'm going to come over here to the code. So before I do that, let me do this. I'm sorry. In the repository, I have other stuff, some cheat sheets and different things I've downloaded, put out there for you. I have a few Python examples of code, we're going to walk through this one right here. This, where is it at? Excuse me, Logistic Regression, Fannie Mae. I'm going to walk you through that in the last 15 minutes I have. And then the other codes out there for you to play with and see. So give me 1 minute to show you the other code real quick so you know. So just so you can see, most of the slides I just showed you with the intro stuff, this little Summit 2020 demo, PY, this is all the basics. So if you can download, set up your environment, and then just walk through these basics, right? At the bottom right here, there's a few more things in here that I didn't show in the slide, right? So for example, at the bottom, I have how you can connect to SQL Server using PyODBC and run and get data. They're in the data folder. There is, if you want to make this example work, in the data folder, there's a baseball CSV file. You can just use the import tool for SQL Server to import that file. Just take the default names that it gives you, and then this code will work for you. So this is where you can walk through the demo examples. Another thing I have is a code out here that I'll show you how to do a random forest. And also, for those of you that want to get real fun and do some TensorFlow and keras, you can look at this package and run. And all you have to do is set up your Anaconda environment and then download this code into a folder and then set up your Anaconda environment. One thing to note is, I forgot to show you this real quick, is in the extensions, make sure you install the Anaconda extension pack and the Python one. So that's through here in Visual Studio. And then once you do that, when you click on a Python file, you're gonna get this blue bar down here. And then you can click on this blue bar and it's gonna let you select the interpreter, right? And so, and then this is all the environments that are installed. And this is what this Anaconda pack gives you. And make sure I get the right environment set for my code to run. So then once you set up the environment, then you can just come run through this code. So this just gives you an example of using some red wine data to predict classifications. So that's there. The other thing is I've mentioned Numpy and Pandas. These are our data packages. This is how we bring data in, read data, use the data, right? So I have a whole bunch of examples in this Pandas Numpy Python of how to read data in using Pandas, and then also how to read the data in using Numpy and to play with the data that way. And it's all commented so you can easily see what's going on. And also at the end, I give a little trick here. It's like, hey, how do I take and create a Pandas data frame from a dictionary, right? So these are files to play with. We only have 1 hour and 15 minutes, so I can't go through everything, but the code's there. You set the environment up. This is why I kind of took the time to show you this. So let's walk through this in like 10 minutes real quick. So what do I have here? I have a script that's going to read this some Fannie Mae data. And this data is data from 2007 that has information of when people defaulted on loans. So if you remember, for those of you old enough to remember, in 2008, there was a big housing crisis in the US where a lot of people defaulted on loans. Well, this is data from the year before that of people who had defaulted on loans. And so in 2007, and so if we look real quick, there is all this information like credit score and things like that, including this loan default. Did they default on a loan or not? And so we're going to use this column to build what's called logistic regression, where logistic regression is a probability between 0 and 1 of somebody defaulting on a loan. So we have all this data. So let me walk through this because I only have probably like 10, 11 minutes left. Walk through what's happening so you can see the code and kind of see it all put together. So I'm bringing in a bunch of packages, right? Oh, excuse me, hit the wrong button. So I'm bringing in Numpy, Pandas, matplotlib, Geopandas. So all these packages are being brought in to allow for me to manipulate this data. So in Visual Studio Code, when I'm in my Python file, if I want to run some code, I can highlight that code. So I'm just going to run this first section that brings the data in. So that's what this Panda data frames is, PD. This is where this is, Pandas as PD. Read Excel, so read the Excel file. It's going to bring it in and load it into a data frame, a Pandas data frame. Like I said, think of a Pandas data frame as a table, and also have this function I set up. And this function is to classify credit scores, so based upon. So let me run that. So I hit Shift-Enter. Shift-Enter runs the current selection. And if you forget, you can right-click, and you can see right here, run selection, Shift-Enter. You can run the current file. You can run to a line. And I'll run it in this interactive window. And so let me just minimize the code for a second. This is this interactive window. This is, wow. Oh, sorry. The reason I got the error is because I opened the file up in Excel and I'm trying to read. And so I didn't do this on purpose, like to be smart, to say, hey, Excel puts a lock on a file. So up here in my interactive window, I have these cool tools. X deletes all the output that I currently had. This one right here will restart my Python environment. So my engine, this is a cool tool. This shows these variables here in my frame here. So I'm just going to click this X to clear out my code, and then I'm going to run this selection again. And now you can see where this is this Python interactive notebook experience. So this is what's using that notebook package I showed earlier. And you can see when I hit this little arrow here, where it runs this code. So now it's reading this code in. I'm going to minimize this window a little. And while this is running, it's going to take a second. I'm going to walk through the code. So what we're doing, we're creating a function so that I can classify good, poor, fair, good. I have good twice. I just noticed that. That should be excellent. I'll update when I get done with the session. I'll push the code up so that's fixed. I didn't realize that I did that. So that should be excellent. So this, you can see where I just have an if statement. I showed you if statement earlier. I showed you a function where we're using this. And I'm going to create a Panda data frame. Think of this Panda data frame as a table. Read it in. Then I have a couple commands. Look at the top few rows of the table. Look at this info will give me information about this Panda data frame. Like what are the columns or the column data types. And then I just had a couple settings to set some graph, some of the matplotlib settings. And then I'm going to do some things like plot the data and look at how many people have defaulted, right? And so if I look right here, here's a cool thing about why I like this environment. If I look right here, I have this show variable viewer. And so because this is a data frame, it gives me this little icon to say, hey, I have a data frame. I recognize this. I can now look at this data frame in Visual Studio Code and see, oh yeah, my data looks good. So I'm going to close that out. So let's just do, I'm on this line. Let's just see what happens next. So this is showing me I have about 90,000 people who default, or 50-something thousand people who defaulted. I've subsetted the data, by the way, and about 8,000 or 9,000 that haven't defaulted. So that's this plot. So I'm just showing you things, how you make plots and stuff. So one thing I'm going to do is I'm going to drop a bunch of columns out of my data set that I know I don't need. And the reason why I know this is because I've actually used a tool called SAS Jump to do initial analysis of all this and build models. And so, so I'm dropping out a lot of columns I don't need. But if I go look in here, this is the head, and this is the info right here. This is showing all my columns, the indexes of those columns in there. How many rows do I have? Notice non-null. Notice I have some missing data because all these numbers aren't the same, because this tells me I have 61804 columns. Notice how some of these don't add up. So I can use this cool function here to see which ones have missing columns, missing data, right? So DTI ratio, I'm missing 1,716 lines. So I'm going to do something I don't normally do as a data scientist, just drop out the missing records. I'm I'm going to do that just because of time's sake. But one thing I normally do is I might try to, in what we call impute and calculate a value to fill in the missing data. But in this case, it's so little, I'm just going to get rid of these 1,716 or so that are missing and get a shorter record set. So if I do this drop NA, so to drop any record that has an NA in it, drop it. And this in place true means just do it with inside the same data frame and keep the data frame. Now when I do that, you can see I have no missing. And notice now all my numbers add up, right? And I gotta hurry. So some things I'm gonna do. Some of these are categorical variables. So like credit score, I'm going to use this function right here to create a categorical variable based upon this credit score. And I have good in here twice. Why? I apologize. I will fix this function. And when we get done in this conversation, I just noticed I'll fix that function. But I'm going to use this lambda, this apply function and data frame to say, apply this function and create this new column in the data frame called credit score class. And then now I can look at my plot. And now we have a lot of goods because as you saw, I have good listed twice. I will fix that and then republish this code very shortly after we're done in a few minutes. But now I have these classification here. One thing, if you noticed earlier when I showed you the values for the loan defaults or yes and no, I want to make those 1 and 0s. So I just took and said, hey, take the loan default, change the yeses and nos to 1 and 0s using this replace. And then I wanted to make sure though, then after I did that, I want to make sure it was a numeric column. So I use this pandas numeric function. So another cool thing is I can use Geopandas and I can bring in this shapefile. The shapefiles in the data thing, the data folder. It just has all the United States since we're looking at United States data. And then I can use a cool summary function in this aggregation function in Pandas data frame to say, hey, by loan default, by state, how many loan defaults do I have? So I just created this states default data frame using this ag function of data frame, a new value. See, that shows me all the states and how many defaults. You can see Florida is really high. And then now I can then take this shapefile and I can merge it with this state default I created. And I end up with a table that has all the shape files, so every state, and then it adds in the account of when they defaulted, right? And so then I can use Geopandas, which is just a package, to then create a cool visual that, no, this is not the election results from the United States. This is showing you in California, we had 1092 defaults, Florida 1115, Texas, and it's shaded. So that's that. And I got to hurry, I got 2 minutes. So I'm going to run all these. So these are going to use this get dummies. And so what this does is right now, if you were to look at the credit score class, it would have one column and with multiple categories. Well, for the scikit-learn class to work, what we need is we need multiple columns with 1 or 0s. So we call it a dummy variable. So that's what this get dummies does. So it's going to create these multiple columns. So if I run right now, this head function, you can see where things like, channel property, see state, see how they have this one column? So when I come through here and I run all these get dummies, and then now I look at it, it still looks the same, right? So then what I'm going to do is, this is just copying the loan default to its own thing. And then what I do is I created all these dummy series here from this get dummies thing. So what I'm going to do now is I'm going to drop out these columns here that I use to create these dummies out of my original data frame. And then I'm going to use the pandas concat function to concat in all those dummy ones I created right here. And then by doing that, I'm going to skip these correlation plots because they take a little time. By doing that, you end up with this. So you see how we have all that. And then give me 1 minute, guys. I know I'm over. Give me 1 minute. Then what I'm going to do is I'm going to split my data into X and Y. So Y is lone default. So that's a 0. That's because I moved it right here. I'm going to split. This is using those slicing. So my X and Y. So my X is is the variables I'm using to predict Y. Y being lone default. I'm using the iload function. So this is just doing it by the index in the data frame. You can also use the names, but as you can see, I'd have to list 70 names. So that's kind of a pain. So that's why I did that. And then I'm using this train split function in scikit-learn. So that splits my data set into 70% training to train my model against and 30% test to test. And then I just use the logistic regression function to build my model. So this is going to predict X from Y. Then I can say, hey, take the test data, use this predict function off of this model I did to see how well I did. And then we can do what's called a create a confusion matrix to see how well our model did. So we can see our model did not very good, actually, at predicting no. We got 408 good. This is not a data science exercise in the sense to really teach you how to do regression models. This is more just to show you how I build a regression model. I can present the classification report, get all that. And then I can do some matplotlib stuff to show you how well we did. So this is kind of putting it all together, right? So that being said, let me go back to my slides. All the code's there. And I thank you for attending. I know I went 2 minutes over. I apologize. You can get all the code on my GitHub repository. So I don't know if there's any questions or if we have time. I apologize, but you can get me on Twitter. You can get me. There's my email. You can email me questions.